Imagine a world so flat, its inhabitants have never looked up. They move forward, backward, left and right, but up and down don't exist to them. They live on a tabletop, your tabletop. To them, it's the entire universe. One day, they send out a probe, a small device designed to explore the farthest edge of their world. It glides smoothly over the table's surface, transmitting data as it goes. But then, silence. The signal is lost. To them, it's a mystery. But you know what happened. It simply fell off the edge. What if we are those flat beings? Now imagine you're one of those creatures, living in two dimensions. You can't even imagine the concept of falling. Your entire understanding of physics is limited to your plane. When the probe disappears, you might invent wild theories. Maybe it evaporated. Maybe space itself broke apart. Maybe the universe ends there. But the truth is simpler and stranger. There's an entire dimension you can't access. Now flip the analogy. We are three-dimensional beings. What if black holes, those mysterious voids in space, are the edges of our dimensional table? Black holes are terrifying and fascinating. They have immense gravitational pull, so strong that not even light can escape once it crosses the event horizon. At the center lies the singularity, a point of infinite density where our laws of physics break down. But here's the mystery. Information, mass, energy, even quantum data seems to disappear into black holes forever. This violates a fundamental law of physics. Information cannot be destroyed. It's called the black hole information paradox. So what really happens at the event horizon? Why does reality seem to fall apart there? Maybe it's not a breakdown. Maybe it's a dimensional boundary, the edge of the table, and the information doesn't vanish. It just moves somewhere we cannot see. Our two great physical theories, Einstein's general relativity and quantum mechanics, completely fall apart at the singularity. Relativity says space-time curves infinitely. Quantum mechanics demands uncertainty, randomness, and conservation, but both can't be right at once. It's not just a mathematical error. It might be a perspective problem. Just like the 2D beings couldn't comprehend falling, we might be unable to grasp the true structure of space because we're missing a dimension, the fourth spatial dimension. Some models suggest our universe is a brain, a kind of membrane floating in a high-dimensional space. In this view, our 3D reality is embedded in a larger, invisible realm. Gravity might be the only force that can leak into this fourth spatial dimension, which could explain why it's so weak compared to other forces. It's being shared with another space we can't see. And black holes? They might be tunnels into this high-dimensional space. Imagine, a star collapses into a black hole. From our point of view, it disappears. But from a high-dimensional perspective, it's still there, just not here. We may never directly see the fourth spatial dimension, but like the 2D beings guessing it up, we might infer its presence through careful study, math, and imagination. So what if black holes aren't the end of information? What if they're just the edge of our dimensional awareness, a boundary we can't cross, a direction we can't travel, a truth we can't yet reach? We may be creatures of 3 dimensions, but our curiosity, that knows no bounds. Maybe, just maybe, the universe is more than we can ever imagine, and black holes aren't monsters, they're windows. Windows into the next dimension.